Good afternoon, or morning, or evening, whatever it is. This is Mr. Gubino. We're going to be doing the integration of rational expressions. I'm going to do probably the first 4 or 5 problems and just give you a little heads up of how to do these types of problems. Just make sure some of these are really extreme, and we have not done a couple of them, but these you need to kind of look at different things that are going on with each. Okay, so let's see if we can get some of these done and do it as painless as possible. Okay. All right. So starting off with number 1, we have x over x squared plus 1. Know that if you have a derivative, if you have an integration and you're looking for this and you have an expression up here and this is the derivative of that expression, this is going to lead you to the natural log of the expression. Okay, so if the numerator is a derivative of the denominator, then it's going to turn into a natural log type question. Okay, if it doesn't, you might have to do a little bit of other calculations that go along with it, but we'll cover those here in just a little bit. So is x a derivative of x squared, basically? And the answer is yeah, it is. Okay, but if I take the antiderivative, I can't get that right away. So usually what I've told you to do is do u substitution. So u sub is going to be the bottom. So du is going to be 2x dx. And notice I need a 2x dx out here. So we can take the 1/2 du over here and get the x dx. So the 1/2 will come out front. And we need the derivative, which is going to be du over u. And that, since that is the natural log, that's the natural log of u. Don't forget the plus c's always on this one. So we're going to plug in back u value of x squared plus 1. And there's that answer. Okay. Oops, sorry. Kicked my thing. Made it go all over the place. All right. Second one. With the second one, can you cancel? So is there a cancellation? Is x minus 1 a factor of this? There are a couple of them in here that you're going to have to do synthetic division or division of the numerator and denominator, and I've showed those in the examples as best I can. So let's just see. Let's go over here. So x minus 1, and the best way to see if x minus 1 cancels is what times negative 1 will give you positive 4, and that answer will be x minus 4. Well, does that give me minus 5x when I distribute? Hey, it does. Alright, so this is x minus 1 over x minus 1 times x minus 4 dx. And since I can cancel this, this is going to leave me with 1 over x minus 4 dx. Alright. Is the numerator a derivative of the denominator? Yep, it is. So this is natural log of the denominator. There's no extra stuff that I need to put in there, plus c. Again, review these, go back through, pause, whatever you need to do. All right, how about the next one? Well, the next one is, oh, this one is fun. All right, so what I'm going to do is I'm going to change this into x times x plus 1 to the 1/2 power. And now I can't distribute the x. and I can't distribute the 1/2 as a power. So what I'm going to do is I'm going to do u sub. And I'm going to let u be the inside of that function, x plus 1. So what we end up getting is, yes, we get u to the 1/2 power. We can figure that one out. We know how to antiderive that. Okay? Du is 1 dx. Oh, okay, so we got 1 dx. Now we have this in there. So this will be du. And we need x. So I need to go back to this equation and go x is equal to u minus 1. I left a space because I knew what I was going to do. Now, with that, now I can distribute the u to the 1/2. And if I take the u to the 1/2 and I distribute it, because this is a power and this is to the first, so I can distribute it. It would be u times u to the 1/2 minus 1 times u to the 1/2 du. I'm going to clean it up just a little bit. U to the first power. Oh, I'm sorry. This is negative. Sorry. Negative 1/2. I apologize. Yep, we got to carry that through. Alright, so u to the first, we can add those exponents. I'm going to get u to the 1/2. And this is going to be just minus u to the negative 1/2 du. I'm going to now integrate each by separate parts. And then eventually what I'll do is I'll replace this x plus 1 back in. So raised by a power, add 1. So that's going to be 3/2. Divide by 3/2, which is 2/3. Minus power, add 1 is going to be u to the 1/2. Divide by 1/2 is multiplying by 2. And add c. So what you're going to do now, after all that good stuff, is you're going to replace back in the x plus 1 and if you want to put it underneath the roots, I think the answer has the roots. I think it's let's see, so you're actually looking at I don't remember, 19. Yeah, number 19. This will go to 19. Alright, this one, more commonly known as 1 plus x squared dx. I put up a video on how to find the derivatives. I also want to make sure that you know that the derivatives of inverse trig functions are formulas that you should know. Put them on your cheat sheet. They may come up. So over here, I am going to post this as well. But these are the general forms. This one gives you arcsine. This one gives you arcsecant. Okay, so it's arcsecant of the absolute value of x. So these forms are going to give you that. Now when you go up here for the derivatives, you notice arcsine of u is going to be whatever u is, the derivative, over 1 minus whatever u is squared. Arccosine is just going to be the negative. Tangent, arctangent, is u over u prime over 1 minus u squared. Arccosine is just the negative. And then the same for secant, arcsecant. Okay, so those are some that you kind of need to know. We didn't have time to go over those, so I'm going to post a video on those. Watch that at your leisure. Alright, so let's get back to this. This is the form of arctangent of x, because there's nothing in there. Now, let's say that that was 1 over 1 plus 4x squared. Well, that is 1 over 1 plus 2x squared. And so that would be that value. All right, so that would be arctan of 2x plus c. But in this case, because it is only the x, that is your only answer that you're going to have for this, okay? So if you see that, if you're squaring a number and squaring a number, and then, oh, sorry, and then I got to multiply by the derivative of that, so the derivative's got to go on the top. So that'll be 2 arc tan of 2x, okay? So that one's a different problem. I just threw that one on there just so you could see if it was a little bit different, we'd go there. I'll throw out Wolfram Alpha.com. That one helps. I think Symbolab. I think it's Symbolab. Also can help you out with those. Okay. So again, if you throw it in the Google search, that'll be okay as well. All right. So this one we're going to write as x over 1 plus, and this is any form of the denominator. So you remember I said right up above, I said we could put it as whatever number is being squared. So we know the derivative of this is 2x. Okay, so if I let u equal x squared, this inside, then what happens is this is 1 plus u squared. So du is 2x dx. So the 1/2 is going to come out front because that's going to go over. And x dx, and that's du. Or 1 du over that. So that is 1/2 arctan of u plus c. So that is, hold on. Sorry, I had a cough there. 1/2 arctan. I'm going to replace u back in with x squared plus c. Now some of these, yeah, you might have are going to struggle with. I struggle with some of them, to be honest. So just make sure that when you're doing these, you see what's going on. So the only difference between these two is that this has a square root on the bottom. So we're going to do kind of the same thing. X over the square root of 1 minus x squared squared dx. I'm going to let u equal x squared. So du is 2x dx. So 1/2 du is x dx. All right, so we got 1/2 du. We'll put the 1. We got the square root of 1 minus u squared. That is over here arcsine. 1 over 1 minus the square root of 1 minus x squared. And that is arcsine. So that's another one that you might need to know. All right, so transition back to here. So this is arcsine of u times 1/2 plus c. And let's throw in that x squared. So there's that. Okay. Arcsine, reminder, is written like this as well. Just like arctan could be written as inverse tangent x squared. 1/2 inverse tangent x squared plus c. All right. So there's that worksheet. Finish up as best you can. Again, as best you can. I'm not, we haven't gone over a couple of those, but if we would have had time, we definitely would have. So good luck on that worksheet, and I will post the answers as well.